Can I take 10 more minutes? No, na? Very good. So, summation 1 upon 1 plus an, right? And this 1 upon 1 plus an going to be 1. This implies this first term, this second term going to be 1. Like an upon bn going to be 1. Then an and bn both are convergent simultaneously. This term is convergent because this is given in the question that the series with this term is convergent, and hence this term is also convergent. So this implies. Okay, my question is where we use this condition? Where we use an and bn going to be greater than. How many people know Python language? Okay, so how many know this function? Because I have a problem. Import C types. Import C types. This number 2, but it is very similar to that first one, right? Right? Are right? Thank you for coming. Right. Thanks. 35, 36, 37, 38, 39, 40, 41, 42, 43, 43, 44, 45, 46, 45, 45, 45, 46, 47. Hello. So, good morning all. This is the second class of tutorial. If you have any doubt in the first class, you can ask right now or after the class. Okay. So, today we are going to discuss 4 questions. Question number 9, question number 11, question number 13, and question number 16. Most probably, there is a problem in question number first E part. So, I'll discuss after these 4 questions. Okay. So the question is this integral 1 to infinity ln x upon x square, is it convergent or divergent? So you have 2 minutes to solve. First hint is you can solve this whole integral. Second method is you can show that this fx, this fx is less than some dx, and that dx is convergent. What I get? So what I get? I get ln p by p and minus 1 by p plus 1 limit equal to infinity. Someone who interested in this can find why this ln x is less than 2x, then you find the complete answer. Okay? Otherwise, don't go for second method. It's very expensive. Don't. Try to solve. At least for p greater than 1, you have to think and have to solve. At least for p greater than 1. Just divide this range of p from 0 to 1 and 1 to infinity. So for p greater than 1, you have to find it. And you have to prove it is convergent. Everyone know comparison? Everyone know? Backbencher? You know comparison test? No. They live in their own planet, they create own planet. Don't worry about what you are discussing about, I don't care. Do you know comparison test? Can we use comparison test here? No, because up to now, sin x by x raised to power p is not positive. It should be positive. This is also the condition for comparison test. Dx and fx should be positive. So I just put this. Now it's true. And also this whole function and this whole function are positive functions. Is it fine? Is it clear? Okay. Now we can use comparison test. So if integral 1 to infinity 1 upon x raised to power p dx is convergent, then integral sin x upon x raised to power p dx is convergent. Now tell me when this integral is convergent. For what value of p this integral is convergent? Greater than 1. So this implies, and we are taking this case, this implies, what is it? Yeah. For p greater than 1, this above means this integral is convergent, implies this integral sin x upon x raised to power p dx is convergent for p greater than 1. Now, if this is convergent, see, this is one more result. If fx dx fx dx is convergent, this implies fx dx is convergent. Okay, if modulus of some function over any limit, let's say a to infinity, is convergent, then without mod it is also convergent. What about that? Do you agree with it now? For this, if mod fx is convergent, integral fx dx is convergent. What about converse? Is it true when fx is convergent, mod fx is also convergent? No, I'm saying, yeah, this is true. Mod fx is convergent, fx is convergent. What about the converse? Not possible, right? But
can I ask you one by one? Not like that.
which it is?
1 minus 1, 2 by 2.
Okay, yeah. Good. So this is your what you call homework. Just find that converse. Maybe this question is will be included in your quiz one. It may be possible. Now everyone get straight. Oh, quiz one. So this may be included in your quiz. Tell me one example of such function such that this whole thing is not true for converse. Okay, I'm getting my point. If this is convergent, but this thing is not convergent, just find some example. Okay. Okay. So yeah. So this implies if this mod is convergent, this integral is going to be convergent. Sin x upon x raised to power p dx is convergent for p greater than or equal to 1. Hey, if you do not understand my this writing, please let me know. I'll try something new. Okay. 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 Now, case number 2. When can I write this? Is it true? See, you have to know how to initiate the question and how to go for it. So first, you have to know why we are going to discuss something. Idea is that if p is between 0 to 1, p plus 1 is between 1 to 1. Now if I find something this, x raised to power p plus 1 type, then we can claim that this is going to be convergent because p plus 1 is greater than 1, correct? P plus 1 is greater than 1. P plus 1 is greater. So now I am going to convert this into some form plus something plus some integral of x raised to power p plus 1 with some form. This is the idea why I am going for this. I am just going to convert this into some x raised to power p, and I claim that this is going to be convergent because p plus 1 is greater than 1, and this one I will deal with this somehow. Okay, now by partial fraction. By partial. The partial fraction is some other. By partial fraction. I do. I just forget. Thank you. So partial fraction is different. Sorry, backbenchers. I told you some wrong thing. This is by part, not by partial fraction. Okay. Okay. Read. It's only 2 terms. 3 terms. What is the
First time you get cos x by x, then again you by y.
1 upon x raised to power p to be second function. Okay, sin x to be first function, 1 upon x raised to power p to. Is it true? Again and again. So this is the expression. I solve using this as first function, and this is to be a second function. We just integrate cos x, put x raised to power t here. For the second term, we just differentiate first term, second term to be integrated. Okay? Any questions? Okay, no question. Fine. So, yeah. Now tell me about this. If this is convergent, this is very similar to this. This is very similar to this. Instead of sin x, I only have cos x. Just consider this: cos x upon x raised to power q, where q is greater than 1. Isn't it? This is p plus 1 is considered as q, and that q is greater than 1 because p plus 1 is greater than 1. That's why q is greater than 1. Now this is same as the case number first, sin x upon x raised to power q type, x raised to power p type, where p is greater than 1. Okay. So this is convergent. So I'm not doing see how this is going to be convergent because this is very similar to that first case, right? Right? Are they right? So this is convergent, same as case first. What about this? For writing purposes. No, you have to just write to it. This is cos b upon b raised to power p, limit b tending to infinity, where p is greater than 1. Tell me this limit. 0. Very good. 0. So this is going to be cos 1. And this is convergent, this is some finite value. I am not writing that value. So what I prove for case number 2, where p is between 0 to 1, the integral is going to be some finite value, and that's why this is convergent. So from case 1 and case 2, we find that what we find? We find that this is convergent for p greater than 0. Is it okay? We just break p greater than 0 to be in two cases, p between 0 to 1 and p greater than 1. For p greater than 1, this is very easy, I thought. For second case, you have to put some very hard work and then find something. Right? Is it okay? Okay. Now, here we go for some very interesting question. Sorry. Here we go for some interesting question. Question number 16. Very, very interesting for the purpose of quiz 1. Sorry.
That previous one, what would p equal to 1? Because the x power p plus 1, that will be from
Is greater than
p equal to 1 case also.
okay, p is over 1 is something. So what the problem is p is equal to 1? This is therefore asking for is any like is this case does not contain p is equal to 1? Just think and ask. Don't worry. You have any doubt, you can ask. Okay. This case consider p is equal to 1. Okay. So here we go for some very interesting question of summation and one question out for your quiz 1 is convergent, then what about summation an? If summation an upon 1 plus an is convergent, what about summation an series? Is it convergent or not? Oh, okay. How? Good. Proud of it. Okay. Proud of every student. So, tell me, you have 1 minute only to solve. Just try. This is very interesting. Very, very, very interesting. hint is, don't ask hint in quizzes because I'm going in this classes, so don't ask me, give me hint in quiz 1 or quiz 2. So yeah. Yeah, limit comparison test. Use limit comparison test. What is limit comparison test? Limit comparison test is when we have an, bn provided, this is very important, provided an and bn both greater than 0, then and limit n tends to infinity an upon bn going to be 1, then both an and bn converges together or diverges together or diverges. This is the hint and this is the limit comparison test. So use this an and bn to be find that the series is some bn such that this is going to be 1. Okay, hello. Out of the contest, how many people know Python language? Okay, so how many know this function? Because I have a problem. Import C type thing. Import C types. Do you? No one know import C type thing? Oh, no. Okay, focus on it. Don't go anywhere. Focus. So, okay, time's up. We are going to form, see, summation an upon 1 plus an, please see very carefully. This is convergent, this implies an upon 1 plus an is going to be 0, right? So, this implies an plus 1 minus 1 upon 1 plus an is going to be 0. Is it fine? I just add 1 and minus 1, okay? This implies 1 minus 1 upon 1 plus an going to be 0. Is it fine? An plus 1. This an is a suffix. An plus 1, 1 upon 1 plus an, this is going to be 1 minus 1 upon 1 plus an. So this implies 1 upon 1 plus an is going to be 1. Is it fine? Is it fine? So it's done. If you find these things, you get the answer. How? Consider bn to be an. I don't know you understand. No, don't mess up. Okay, consider this. An upon 1 plus an upon an. An upon 1 plus an upon an. This is going to be 1 upon 1 plus an, right? And this 1 upon 1 plus an going to be 1. This implies this first term, this second term going to be 1. Like an upon bn going to be 1. Then an and bn both are what do you call convergent simultaneously. This term is convergent because this is given in the question that the series with this term is convergent and hence this term is also convergent. So this implies summation an is. Everyone should know and can understand this one. Please understand. This is very important. I told you this may be for you in this question. Okay, don't be serious. This is very important question. So, yeah. Okay, my question is where we use this condition. Where we use an and bn going to be greater than 0. And in your question it is given that an is a positive term. I just missed to write. An is a positive term series. It is given in your question. So if it is not given, can we do the same thing? This is my question. And this may be your- Okay. So think of it and let me know in next tutorial if you get the answer where we are using this an and bn greater than 0. Okay, backbenchers? You will tell. Yeah. Okay, so this is question number 16. Now I'm going to for question number 13. N upon ln. Okay, one more question I have here. What about converse? If summation an upon 1 plus, summation an is convergent and an is positive, what about an upon 1 plus an? Is it convergent or not? Is it convergent or not?
Yes.
So what?
Always greater than.
Good? I thought no one can answer. Okay. No worries. So okay. an upon 1 plus. My question is, summation an is convergent. Then what about an upon 1 plus an? So this is an upon 1 plus an is always less than an. Condition when an is greater than 0. Otherwise this is not possible. If an is not greater than 0, this thing doesn't hold. Got it? Because if an is positive, let's say if I say is 3 upon 1 minus 3 is less than somehow it is not. Okay, if we take an negative, then this thing is not. Okay? That's someone says this. This is not true, right? This is not true. So this is only true if an is positive. And since this series is the series with this term is convergent, and hence the series with this an upon 1 plus n is also convergent. Is it fine? Is it clear? Is it clear? How that goes? No, sir. Okay. Okay, one more. So the question is, can I take 10 more minutes? No, na? Very good. So summation n upon ln n power alpha. That's over. Try this question in your home and let's try next video. Okay. So this time for attendance. So just keep quiet for attendance and give your attendance very carefully. If you miss your roll number, you will miss your attendance. Okay. Okay.
Then roll number CH23 B108.
108 बोलो बच्चों.
108 109 110 111 112 15 16 16 32 is not in the list. 33 34 34
35 36 37 38 39 40 41 42 43 43 44 45 46 45 45 45 46 47 47 48 49 50 51 52 53 54 53 53 54 55 55 56 57 58 59 60 61 62 53 54 55 56 57 58 59 69 69 70 71 71 71 72 73 74.
no not
Okay, thank you for coming. And thanks. If I give this example, this is going to be one, right? This term. But this series is not convergent. This series is not convergent. I am saying that term going to be 0, not whole series. This is not going to be 0. This is going to be 0. Got it? This term going to be 0, not the whole series. Is it fine? For example, you just, what about this? Do you know? This is convergent or not? No.
Means 1 by n is convergent, but series is.
Well, 1 by n is convergent, but series is not convergent. So this is the necessary condition for a series to be convergent. Like if series is convergent, term going to be 0. if term going to be 0 does not imply series is convergent. Is it fine? Just think and ask me again. Just think this thing, okay? Just read the whatever the sir told you. Just read and then ask me. Free to ask, no worry, okay? Yeah.
Sin x by x power p, where 0 to
This is question number 12. I'll consider this for next week. Okay?
Sir, next week can you explain 17?
Yeah, I'll
So
consider.
could you give hint?
Okay.
For 0 to infinity,
Okay.
for converges for p between 0 to 1. We already proved that from 1 to infinity this converges for p between 0 and 1. So we have to prove convergence only from 0 to 1.
Any other question?
Next.
Thank you. Yeah, C-type.
C-type is basically the library that helps to import any function and
Yeah, I understand, but I just write one code. See, this one. So I'm writing this code and I just want to implement this an array from the C type. This is a Python code. I just want to create an array of C type here. But I get some error. I don't know what error this is. That's why I'm asking. So this is working for if I take one integer. Like if I take instead of array, I just take one integer. Then C type is working. But if I going for an array, I just want to create an array there. Then it's showing some error. I don't know.
let me show there.
Yeah.
unsupported apparent parents or integer range. I guess there is some type error here. Like, so are you putting floating points or just integers?
Just integer.
You check once the syntax, proper syntax for creating a C-type array. Like if it's working for one integer, I guess it is taking just one integer. Like it is a syntax for taking one integer. You check the ChatGPT if you take from ChatGPT, it really gives very bad. Don't use that. Try it in Google. That put this thing properly in Google. They will show some stack exchange there is the website that they solve problems better. And you can I think it's a majorly problem because of the allocation. See like this. Wait a minute. I can change one thing. Yeah. Oh, now how will I done? Module C-type is not same array. Check this thing once. I think why are you using C-type for taking an array? You can use number.
Then I will take a C type because see I'm working with the CPP code and I just want this CPP code to run here. That's why I'm creating
It is like a shell program to run the code.
Exactly. That's why I just want this C type array.
No, array for input array can be anything, I guess. Okay, you check the C-type. I am also not sure about this C-type array. Like you can check two things. Either modify this code with C-type or you can use NumPy. Okay. NumPy it also creates it is easier to create array in NumPy. Like it is basically made to handle array data. So and for you are just importing the array in this program, nothing else. So you just create array in NumPy and just import the array to the.
But this array should be used here.
Okay, fine. Like
NumPy will work.
I think it will work. Yeah, I think it will work. First, one thing you can do is C int array should be an empty list. Then you append each of the integer by inputting it. You can check you can check C type also. You can check NumPy also. Both of them work fine. And then I will see.
Okay. Just see and I'll let you know in the next tutorial. Okay? Yeah, thank you.
Why are you using C type for taking an array? You can use NumPy.
NumPy will take a C type because see I'm working with the CPP code and I just want this CPP code to run here. That's why I'm creating
It is like a shell program to run the code.
Exactly. That's why I just want this C type array.
No, array for input array can be anything, I guess. Okay, you check the C type. I am also not sure about this C type array. Like you can check two things. Either modify this code with C type or you can use NumPy. Okay. NumPy it also creates it is easier to create array in NumPy. Like it is basically made to handle array data. So and for you are just importing the array in this program, nothing else. So you just create array in NumPy and just import the array to the.
But this array should be used here.
Okay, fine. Like
NumPy will work.
I think it will work. Yeah, I think it will work. First, one thing you can do is C int array should be an empty list. Then you append each of the integer by inputting it. You can check you can check C type also. You can check NumPy also. Both of them work fine. And then I will see.
Okay. Just see and I'll let you know in the next tutorial. Okay? Yeah, thank you.
धन्यवाद आपका।